What's up everyone, Patrick here, welcome back. Moving on to the next question dealing with circles. So notice there's a lot written out here. If you don't want to write this out, you could just print out the lecture notes. They're at the beginning of the section. If you're watching this on YouTube, you can go to the description box and there will be a link that will take you to the course website where those lecture notes are on. So we're given a circle, x squared plus y squared is equal to 53. So a couple of questions dealing with that circle. So part A, we have to verify that 7, -2, and -2 and 7 is a chord, or the endpoints of a chord. Part B, we have to find the equation from the midpoint of the chord to the center of the circle. And then in part C, we have to verify the line is perpendicular to the chord. So this question here, very similar to the previous question that we did where we were dealing with a right bisector of a chord. This is just another way to go about it to prove that conjecture or that theorem, quote unquote, that we discussed before. So before getting into the technical stuff, I'm going to draw just a diagram of what's going to happen here. So we have this circle x squared plus y squared equals 53. Now notice that that circle has a center of 0 and 0. Whenever you have a circle, x squared plus y squared is equal to r squared. Whenever the left side looks like this, there's just an x squared plus y squared on the left side, then that circle is always going to have a center of 0 and 0. So at the origin, so if we draw a circle, first thing we got to do is verify that 7, -2, and -2, 7 is a chord. And so another way that could be worded is that we have to verify that these 2 points lie on the circle. Because a chord of a circle is basically any line that joins 2 points that are on the circle. So whether there, could be anywhere. Okay, so when we have to verify that 2 points are the endpoints of a chord, it's the same thing as verifying that those 2 points are actually on the circle, which we've done questions like before, right? So don't get confused with the wording. Both of them mean the same thing. 7, -2 would be approximately, so positive 7, -2, let's say that's like over here. So this is 7, -2. And then we have -2, an x value -2, and then a y value of positive 7. So let's say that's going to be like up here. Right? So we have to first verify that those are the endpoints of a chord, or that those points are on the circle. So if we draw the chord, it's going to look like that. Then what we have to do is we have to find the equation from the midpoint of the chord to the center of the circle. So the equation of the line, I should have wrote line here. Right, from the midpoint of the chord, which is going to be like over here, let's say, somewhere over here, and then to the center of the circle, which is at 0 and 0. So we have to find the equation of this line over here. And then in part C, we have to verify that that line right there is perpendicular to the chord, meaning that there's a 90-degree angle between this line and this line, or that the slopes are negative reciprocals of one another. Okay, and if this is perpendicular to this line and it's going through the midpoint, then notice that this line, it's going to end up being the right bisector. And as we stated in a previous video, the right bisector of any chord that you draw on a circle, so whether that would be here, whether that would be here, right? Any right bisector of a chord is always going to go through the center of the circle. So this is just another way kind of going backwards to show that that happens. Before, what we did was we found the equation of a right bisector of a chord and then verified that it went through 0 and 0. Here we're kind of going backwards and actually drawing the line from 0 to, from the origin or from the center of the circle to the midpoint, and then verifying that these 2 lines are going to be perpendicular. So just another way to go about that theorem. So starting with part A, we got to verify that 7, -2, -2, 7 are the endpoints of a chord, or that they lie on the circle. How do we do that? Well, we take the equation of the circle, and then we just plug in the x and y values for each point, and we just got to make sure that the left side is going to equal the right side. So we'd have 49 plus 4. Notice in this case, 53 is equal to 53. So we confirmed that this point lies on it, and then we got -2 and 7. So that'll be that. That'll be that. And then same thing, this will be 4, this will be 49, equals 53. Left side is equal to the right side, right? So that's the work to show, to verify that those points lie on the circle, or that those points are the endpoints of a chord. So now moving on to part B, we have to find the equation of the line from the midpoint of the chord, which is going to be over here. We're going to have to find that midpoint to the center of the circle, to here, so which is 0 and 0. So let's find first the midpoint of the chord. Now, midpoint just in general, what's the formula? x1 plus x2 divided by 2, y1 plus y2 divided by 2. So the midpoint between these 2 points, so let's let this be x1, y1. Let's let this be x2, y2, sorry. And so plugging everything in, we'll have -2 for x1 plus 7. That's going to be divided by 2. Then we're going to have y1, which is 7, plus y2, which is -2. And then that's going to be divided by 2. So notice -2 plus 7, that's going to give us 5. So we'd end up with 5 over 2. I'm going to keep it as a fraction. 7 plus -2 is like 7 minus 2, right? The plus and the negative turn into a negative. 7 minus 2 is 5 as well. So we'd end up with 5 over 2 over here. So 5 over 2, 5 over 2, or 2.5, 2.5. You can work with decimals if your teacher allows it. Fractions are tougher to work with, and in case your teacher requires you to work with fractions, that's what I'm going to work with. So this point, this midpoint, is, let's actually draw maybe like a line here. It's 5 over 2, 5 over 2. And notice with our diagram, that point makes sense as well. A positive x value, a positive y value. All right, so that's the midpoint. We know the center of the circle is 0 and 0. So really what we got to do now is just find the equation of a line that passes through 0 and 0, and then 5 over 2 and 5 over 2. So first thing we could do is find the slope. So we'll have y2 minus y1 over x2 minus x1. So let's label these. This will be x1, y1. This will be x2, y2. So we'd end up with 5 over 2 minus 0 over 5 over 2 minus 0. And that will give us 5 over 2 divided by 5 over 2, which something divided by that same thing is just going to give us 1. Okay, so the slope of this line here, it's just equal to 1. And then the b value, because this line is going through the origin, notice that the b value, which is the y-intercept, is just going to be 0. So we have y equals just x, right? 1x plus 0. Now, if you wanted to show the work, we would do y equals mx, which is just 1x, so x plus b. And then to solve for that b value, you could plug in either point. You could plug in 0, 0, and then you'd end up with a b value 0, or you could plug in 5 over 2, 5 over 2. You'd end up with a b value of 0. You may also be using that formula to solve for the b value, and if you use that as well, you would still get that b value of 0. So whichever way you do it, B is 0 because the y-intercept of that line is going to be 0. So that is y equals x is just the answer to part B. And then part C, we have to verify that the line, this line, is perpendicular to the chord right here. Okay, so we have this line, which is y equals x. How do we verify that two lines are perpendicular? Well, the slopes have to be negative reciprocals of one another. So we know that this line, it has a slope of 1. So what we got to do now is just find the slope of this line, and then if they're negative reciprocals, then we verify that they're perpendicular. So we already have these labeled x1, y1, x2, y2, so let's just find the slope of those. So we'll have negative 2 minus y1, which is 7, all over x2, which is 7, minus x1, which is negative 2. Just be careful with the brackets right there. We're subtracting a negative value. So we'd end up with what? Negative 2 minus 7 is negative 9. 7 minus negative 2 is the same as 7 plus 2. The two negatives turn into a positive, so we'd end up with positive 9, which would give us negative 1. So the slope of this line, the chord, is negative 1. The slope of this line is positive 1. Notice negative 1, positive 1, those are negative reciprocals of one another, right? If we take 1, which is just over 1, and then flip it, change the sign, it will just be 1 over 1 again, and then we'll put a negative there, which would just give us negative 1. Okay, so positive 1, a slope of positive 1, a slope of negative 1 for the chord. Because they're negative reciprocals of one another, the slopes are negative reciprocals, we confirm that both lines are perpendicular, and we basically confirm or give another example of how that theorem that we've talked about before works, of how when you take a chord and then you find the right bisector of it, that right bisector is always going to pass through the center of the circle.